If you follow the whole conversation around climate change, it can feel like you're just stuck in the middle of a shouting match. There are so many conflicting claims, so many confusing numbers, it's just plain noisy. So today, we're going to try to tune all of that out and really focus on one single, powerful, and let's be honest, often misunderstood number that sits right at the heart of this entire debate.
So let's just get right to it. You've heard this number, right? 97%. It seems like it's either held up as the ultimate proof or just dismissed as a complete myth. So what's the real story? Is this consensus actually a fact, or is it just a convenient talking point? We're going to follow the evidence and find out.
Okay, but before we can even begin to talk about a consensus, we all have to get on the same page about the basic science. I mean, how does our planet stay warm in the first place? Well, it all comes down to a really fundamental process, something you can almost think of as the planet's very own heat blanket.
And this natural process is just incredibly powerful. Gases like carbon dioxide act like a blanket, trapping heat and keeping our planet about 33 degrees Celsius warmer than it would be otherwise. Without it, Earth would be a frozen, totally uninhabitable world. So the greenhouse effect itself, that's not the problem. It's absolutely essential for life. The real question is, what happens when we start thickening that blanket?
And we have thickened it a lot. For thousands and thousands of years, CO2 levels were pretty stable, right around 280 parts per million. But just look at where we are today, over 415 ppm. That's a level our planet hasn't seen in all of human history, and it's driven primarily by burning fossil fuels. We fundamentally changed our atmosphere in just a couple of centuries.
All right, so with that basic physics in mind, now we can finally tackle that big headline number. It's time to decode the 97%, to see where it comes from, and, maybe more importantly, what it actually means. There it is, 97%. It's a huge, almost overwhelming figure. But is it actually backed up by real evidence? Let's break down the studies that got us to this number. Now, the crucial thing to get here is that this number doesn't just come from a single poll. It's a conclusion that's been drawn from multiple independent lines of evidence. For instance, there was a landmark study back in 2013 that analyzed nearly 12,000 peer-reviewed climate papers. And of those papers that actually stated a position, 97% of them endorsed human-caused warming. NASA's own data confirms this. But here's the part that's maybe the most telling. When you narrow the focus to only the most published, most active climate scientists, the real top experts in the field, the agreement climbs to basically 100%. This quote from a scientific survey, it really just sums it all up, doesn't it? While you might see these heated debates on TV or all over social media, among the actual experts, the people who research and publish in this field day in and day out, that core debate is over. The science is settled on some fundamental truths. And this is so key. The 97% consensus isn't about every single little detail. It's not about whether a specific city will get exactly 10% more rain 50 years from now. It's an agreement on two foundational facts. One, the planet is warming up. And two, our activities, mainly our greenhouse gas emissions, are the main driver. The disagreements that are left, they're about the details, not the fundamentals. So, if the core science is settled, then what's even left to debate? Well, a lot, actually. Accepting the consensus doesn't end the conversation. It's really where the real conversation begins. Because in the real world, rising CO2 creates this incredibly complex set of trade-offs, with both some upsides and some very serious downsides. A really balanced view has to acknowledge both sides of this coin. On one hand, CO2 is literally plant food. Higher CO2 can boost crop yields. It can make plants more water efficient. And we're also seeing economic opportunities pop up in the transition to clean energy. But on the other side of that coin, the downsides are severe. More extreme heat, more intense storms, rising sea levels, and a whole host of negative health impacts. So which side of the ledger wins out? Well, when we look at the net effect, especially for things like agriculture, the picture gets a lot clearer. Yes, more CO2 can act like a fertilizer, but the negative impacts of heat stress, drought, and extreme weather are actually projected to overwhelm that benefit. That means we're likely looking at an overall decrease in yields for the world's major crops. The downsides, it seems, ultimately outweigh the upsides.
And what about the economy? This is a really fascinating finding. Just look at the chart. For every $1 million you invest, clean energy and efficiency create significantly more jobs than that same investment in fossil fuels. And the reason is pretty simple, actually.
Building solar farms, installing wind turbines, retrofitting buildings, it's all just more labor-intensive work. So this really shows that the energy transition can be a net positive for employment.
Okay, so we've established the basic physics, and we've looked at the overwhelming scientific consensus. This brings us to the final and, I think, most important step, moving from these established facts to the choices that we have to make as a society.
This is where this idea of being a climate realist comes into play. It's not about being an alarmist, and it's not about being in denial. It's about looking at the scientific evidence clearly, acknowledging both the risks and the opportunities, and then using that information to make practical, proactive decisions, just like we would with any other major challenge we face.
And let's be really clear about the role of science here. That 97% consensus, it doesn't tell us exactly what to do. It doesn't write our laws or pick our technologies for us. What it does is provide the solid, factual foundation. It gives us that shared reality that we need to have a productive debate about the best path forward, weighing all the costs and all the benefits. So, in the end, we're left with this. Decades of research have produced an overwhelming consensus on the basic facts. The science has done its job. The path forward from here, well, that's not a scientific question anymore. It's a human one. It is our choice. And the question for all of us is, what will that choice be?